And away we go. The sine ratio. Section 7.2. Let's read through this. Hi, Misha. We're just going through 7.2 if you want to grab that from the box. I'm just recording, so it won't stop. When triangles are similar, the ratio of the length of the opposite side at a given angle to the length of the hypotenuse is always the same. This ratio is referred to as the sine ratio. Given any right triangle with an acute small, more than 90 angle, A, the sine ratio can be written as follows. The sine of angle A is the length of the opposite side, opposite to angle A, divided by or over the length of the hypotenuse. We usually abbreviate it like this. Sine of A is opposite over hypotenuse. If you look up over there on the poster, I have that sine, I have the angle theta instead of A, but it's a variable, opposite over hypotenuse. I've drawn triangles in all kinds of different orientations, upside down, right side up, that kind of stuff, left, right, reversed. They all work out the same way for the sine angle. Now, what do I mean if I ask you to calculate the value of sine of A to 2 decimal places? Well, let's take a look at these examples. So this one, you might want to do this on the left of your sheet, maybe about here. But I'll do it just below because I don't have the space. I know you do. So in this case, the sine of A is opposite over hypotenuse. This is angle A. So the side that is opposite angle A is 4.3 meters. So that's going to be my opposite. Divided by the hypotenuse, which is the 6.9. Okay, it's hard to see that decimal in the 4.3, but it's there. I'm going to rewrite it just so that if somebody takes a look at a printed example here. Let's see, 6.9. Now that's the ratio. You could use your calculator to divide that, and you get decimal 623. If you do it right, you'll always have sine values that are between, or that are less than 1. You'll never get 1.5 or something like that on a sine value. Now, I could twist the triangle around so that angle A in this case comes over here. And you're given 3 things. The other one was easier because you only had 2 numbers. So this one, you got to make sure you get the right numbers in. So the sine of angle A is the opposite side. You can see that the opposite side, always write down the formula first. And the opposite side in this case is 5.2 inches. The units always divide out, so you don't have to put them in, as long as the units match on the original. And then the hypotenuse, well, the hypotenuse is across from 90 degrees. It's 9.6, which in this case, to reduce, you'd enter it in your calculator and divide it out 0.542. I said to 2 decimal, I guess the problem said to 2 decimal places, and I went to 3. So he could have scratched those off, but there's no harm in doing an extra one. But you should follow directions, okay? So we got this. Well, if you don't, visit back, because I better get this going for the next one. If you need to pause the video to copy something, I'll do that. Okay, example 2, to work through with this. So work along with me, Tori and Misha. The sine ratio can be used to help find the missing parts of a triangle. A ladder 8.5 meters long makes an angle of 72 degrees with the ground. How far up the side of the building will it reach? First, you'd sketch a diagram. I have it for you. The important part of this diagram is this triangle right here. From here, 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 right? The rest of the diagram is good, but it's not as important as that triangle. That's really what you wanted. Now, we've got to find how far up the side of the building it is. You'll notice right here, there's a little H there, and I'll make it bigger. That's the height that we want, right? How far up the building does it go? We have angle A here, and it didn't have to be called A. It could have been just whatever. And we happen to know that it's measured to be 72 degrees. We have the hypotenuse. The hypotenuse is 8.5. So, in this case, we got to work around a different way. This is where the calculator is totally necessary. You need the sine button on it. You'll need cosine and tangent buttons later. So how does this work? Well, we still use this sine. In this case, letter A is equal to the opposite side of the hypotenuse. Then we actually fill in what we have. In this case, as much information as we can. We know that angle A is actually 72 degrees. So I'm going to write down sine 72 degrees is equal to the opposite. When I look at this, though, I see that the opposite side is one that I don't have a number for. So we're going to put in, we call it the height, so H, for the height up the side of the building. And the hypotenuse is 8.5 meters. Yeah. Now, stop for a second, make sure you're with me. This is just getting the stuff from the diagram. Drawing the diagram is, some people find that the toughest part. Let me just move this up a bit more space. Now, in a sense, this is the easy part. You're going to type in your calculator, and Tori, you try it right now. I think that calculator works where you press the sine button first. Press sine button and then 72, and tell me what you get for decimals. 3 decimal places. Does that say decimal 951? Yes? Okay, perfect. That's what you're replacing this with. Sine of 72 is decimal 951. That's equal to the H over H.5. Now, this almost looks like an equation you guys can easily solve. If you want to make it look more like the equations that we typically solve, because then you can cross multiply, divide by the loaner, put that decimal 951 out of the number 1. 1 divided by 1 never changes something, but some people find it easier to see the ratios. And you know how to cross multiply 8.5 times decimal 951. Divide by the loaner, and you'll get your height. And I'll wait for a second and see what you do get for a height. Yep. What do you got? 8.08. 8.08? Sure. Since that sounds good, and since though the original measurement was, the ladder was 8.5 meters long, let's get it to 1 decimal place. So instead of 8.08, does that round up or down to 1 spot? Or does it stay the same? Doesn't matter then. Round up to 8.1. Perfect. Height, 8.1 meters up the side of the building, right? Okay. I'll give you a second here to catch up if you need to, and we'll do one more example. Okay, another example. So flip the page, example 3, and then we're going to be, I'll turn you free on these things. Brad is building a ramp. The ramp must form an angle of 22 degrees with the level ground. And reach a point that's 1.5 meters above the ground. How long is that ramp? Sketch a diagram, first thing. I've got the diagram sketched. right? A right triangle is formed. Indicate that little 90 degrees. So this part is the ramp right here, the hypotenuse. The 22 degrees you can see is labeled in here in this corner A. You don't have to call it A, and often problems won't. Just to make it, I guess, like the other examples so far we've done that. So what are you going to do here? We're going to use the sine ratio, and so far this section is easy because you haven't stopped. Everything you can assume is the sine angle. You draw an angle, correct? Now, the sine ratio. As a reminder, the sine of A is opposite over hypotenuse. Well, we take a look at this. In this case, the sine of 22, that's the A, equal to opposite. 1.5 is the opposite. You'll notice that the C value is the hypotenuse. The opposite is 1.5 meters over the C value for the hypotenuse. Once again, you type that into your calculator, sine of 22, and hit the key. I'll wait for a second, and you'll tell me a decimal number to 3 digits, accurately round it to 3. 375, great. Decimal, 375. We're going to put that out of 1 so that it looks more like an equation that you're used to solving. You don't have to do that, but it helps. Yep. Now, cross multiply, divide by the loner, right? You're going to go 1.5 times 1. And divide by the loner, divide by 375, decimal 375. Okay. Perfect, 4, yeah. So C equals 4 meters. So to make a sentence out of that, we were trying to find the ramp length. So 4 meters is the length of the ramp. Good. Now you should have the tools, as long as you have one of those calculators, you can solve these problems. I'm going to stop the recording and give you a hand if you need, and we can go back to that first example. I think you might have gotten caught on that without doing everything. So I'm going to stop.